Hello. Hello, my dear friends. I hope the live is clear now. Okay, fine. Now, in our last class of our GOC, up to now we have did the lecture number 1, lecture number 2 and the lecture number 3. In our lecture number 3, we have studied about the mesomeric effect and different types of the conjugation. What is the meaning of the different types of the conjugation? Different types of the conjugation is nothing but delocalizations only. How the pi delocalization, clear? And after that, after the pi delocalization, pi cation and pi lone pair and the pi free radical and which one? Lone pair and the vacant orbital. This all the delocalizations or conjugations we have seen very clearly. Done. Now in this lecture we are going to see about how the mesomeric effect will play a very crucial role in the which one? On the benzene. How it is playing very crucial role on the benzene. Now before going that one, now with the help of this molecular model, I will explain very clearly how it is helping the mesomeric effect or it is playing the very crucial role on the benzene. Done. Now here we'll move to the one. Now here how the what delocalization on benzene, how the delocalization on the benzene it is happening. Now we'll see here. If you take the benzene, now this is a benzene, right? 6 carbons and 6 hydrogens. Clear? Namaste. Clear? Namaste Rishika. Now see, now this is a benzene, right? Now in the benzene we are having the 6 carbons and how many hydrogens? 6 hydrogens. All are sp2 hybridized. And the very important and the very key point is hybridization to happen or mesomeric effect to show or delocalization to happen. What is the main key point? All the atoms should be in the plane. If any atom for the benzene, if it is attached and that lone pair containing species and the benzene pi bond, you can see this is a benzene pi bond, both are parallel to each other. Both are parallel to each other. How the both are parallel to each other? Now with the help of just one thing. Now 1 minute, I will search here. Hello Praneeth. Now here you can see for the benzene. Now here this is aniline. What is this one? This is a aniline. Namaste Kirtana. Good evening. Now you see. Now in the benzene, this is a aniline, right? This aniline, now aniline contain what? This is a one lone pair. Nitrogen NH2 will contain the one lone pair, right? Now why the aniline will increase the electron density on the benzene? Why? Because to delocalization to happen, now if you can see it from here, delocalization to happen, all the atoms should be in the plane, right? All the atoms should be in the plane. Now this benzene pi bond and this NH2 lone pair both should be in the which one? Both should be in the parallel to each other. How they are parallel to each other? Now we'll see. Now this pi bond is formed by the pure p orbital of the sp2, we know. Now you can see. Now it will be very clear for you. Nitrogen lone pair of electron and the benzene pure p orbital. Both are which one? They are not perpendicular to each other, they are parallel to each other. In this manner, if you see, you will get to know. Clear? Both are parallel to each other. Is it clear? Both are parallel to each other. That's the reason only any lone pair containing species will increase the electron density on the benzene. Will increase the electron density on the benzene. If you remember this key point, if you remember this one very important key point, now whatever may be the questions they may ask from the mesomeric effect, you will not get any mistake, or you will not do any mistakes. Now we'll start the class on the basis of mesomeric effect. Clear? Now we'll see. Now how the benzene is playing the very important role. How the benzene is playing very important role in the mesomeric effect. Now we'll see. Now in the delocalization of the benzene, already we have seen. Now this is a benzene, right? Now this is a benzene. Now in this benzene, now we are having the 3 pi bonds, and these 3 pi bonds are formed by the which one? Delocalization of which one? sp2. All are formed by the sp2, and these pi bonds are formed by the pure p orbital. Done. Now in this pure p orbital, now how the delocalization will be happen in the benzene? Now this pi bond will be resonate here, and this pi bond will be resonate here, and this pi bond will be resonate here. Done. Now this is the resonating structure of benzene. In between these two resonating structures, actual resonating hybrid will be there for the benzene. Now actual resonating hybrid for the benzene will be in this manner. Now this is the actual resonating structure of the benzene. Now how they got to know the actual resonating structure of the benzene? Actual resonating structure of the benzene, now bond length, they have found that all the carbon, this carbon and this carbon and this carbon and this carbon, all the carbons bond length, they have found that it is having the 1.39 angstrom. Now before they have seen that carbon and the carbon bond length, they have found that it is 1.54 angstrom. Then after that they have found that carbon double bond carbon, this carbon double bond carbon, they have found that it is having the 1.34 angstrom. 34 angstrom. Good evening. Tactic. Who is this tactic? May I know name of this tactic? Good evening, good evening. Now here they will ask you the different resonating structures are here in the benzene. How many resonating structures are possible, they will ask. Clear? For the benzene, we know the benzene, the number of resonating structures are 2 only. Already we have seen, right? Clear? Only the 2 resonating structures are possible for the which one? Benzene. Now here next, if they have given the naphthalene, this is a naphthalene. In this naphthalene, how many resonating structures are possible if they ask? Now directly you can say, this is the one formula, one key formula you have to use, that is n plus 1. N plus 1. Here the n is the number of benzene rings. Clear? Here the number of benzene rings are 2, and plus 1 will give you the how many? 3. Clear? For the naphthalene, 3 resonating structures are possible. Clear? Then next, anthracene, if they have given. Done. Now for this anthracene, how many resonating structures are possible? Now if anyone is in the live, can anyone say the answer for it? If anyone is in the live, can anyone say the answer for this one? Now, how many resonating structures are possible for this one? How many resonating structures are possible for this one? 4. Good. How come? This is 3 benzenes. Now, n plus 1 will be the, yes, 4. N plus 1 will be the 4 resonating structures are possible. 4 resonating structures are possible for this one. Next. Here, if suppose 1 phenanthracene if they have given. Done. Clear? No. Here 1, and here 1. If they have given, then how many resonating structures are possible? If this structure if they have given, how many resonating structures are possible for this one? Can anyone? Now, here the resonating structures possible for this one will be the n plus 2 for this one, because this is not in the plane. Here, these 3 all are in the plane. So, n plus n will give you the resonating structures for these 3. This 3, n plus n will give you the resonating structures. But when it comes to this one, this is not in the plane. When it is not in the plane, that's the reason for this one. Here, the number of resonating structures will be n plus 2. Then the number of resonating structures will be for this one will be the 5. Then the 5 resonating structures are possible for this one. Done. Now, next. Here, already in the lecture number 3, we have studied about the which one? Plus M groups. Clear? Plus M groups we have studied. What are the plus M groups and what are the minus M groups? Now, plus M groups are nothing but which one? Lone pair containing species that if it is attached to the sp2 carbon or any deficient carbon, then that lone pair containing species will act as a plus M. Already we have studied. Then if that lone pair containing species, if it is attached to the benzene, then what it will do? Clear? This is a benzene. This is a one benzene. This is one benzene. Now, for this benzene, if one group is attached, for this group, with respect to this group, now this is a ortho position. With respect to this group on the benzene, these adjacent carbons are ortho. These adjacent carbons are which one? Ortho. Done. Now, increase the electron density at ortho and para. Good. Now, these positions are meta. These positions are meta. And this position is a para. Done. Now, this is how the benzene, if any group is attached, whether the electron density will be increased or whether the electron density will be decreased. This is about this one. Now, first, if any plus M group is which one? Plus M group on benzene. If the plus M groups are on the benzene, what it will happen? Now we'll see. Just now I explained very clearly with this one. If any plus M group is there, here this benzene and this pi electrons both are in parallel to each other. When these both are parallel to each other, this pi electron will increase the electron density on the benzene at which and which positions? If any plus M group, example of the plus M group, I was taking the which one? Aniline. Now this is the aniline. Now the one key point you have to remember. What you have to remember? Nitrogen lone pair and benzene. Nitrogen lone pair and benzene pi bond. Benzene pi bonds are parallel to each other. They are parallel to each other. Clear? That's the reason only delocalization or will be happened. Then how it will be increased? This nitrogen lone pair of electron will be given to the carbon, and this carbon pi bond will be shifted to here. Now how the resonance will be happened? Now in this manner the resonance will be happened. Here the carbon will get the negative charge. Now here the pi bond. Now here the pi bond. Now the double bond, and the nitrogen will get the positive charge, and here it is a NH2. Done. Next one we are having the, again this negative charge will be delocalized, and this pi bond will be shifted here. Done. Now here this carbon will get the negative charge, and here the what? Pi bonds, and here the N, and here it is a plus, and here it is a H2. Done. Next, again this negative charge will be delocalized, and this pi bond will be shifted toward this carbon. Now what you will get? Now this nitrogen will get the negative charge, and here is a NH2. Clear? And here it is a pi bond, and here it is a pi bond. Again this negative charge will be delocalized, and this pi electron will be shifted towards a nitrogen. Done. Now here, now again you can get the same resonating structure. Now this is a resonating structure. If any plus M groups are attached to the, if any plus M groups are attached on the benzene, it will increase the electron density. What it will do? What is a very key point you have to remember? If any plus M groups on benzene increases the electron density, increases the electron density at ortho and para positions, at ortho and the para positions. Clear? At the ortho and the para positions. Clear? Now done. If minus M groups are attached, if minus M groups are on benzene C6H6, if the minus M groups are on the benzene, if the minus M groups are on the benzene, what it will happen? What it will happen to the benzene? Now we have to see. If the minus M groups are on the benzene, what it will happen? Now here the best example I was taking for the minus M group, that is NO2. Now this is a NO2. Now many of the students, they will get a difficulty in identifying the NO2, whether it is a minus M group or plus M group. Done. Now NO2 is a minus M group. Why the NO2 is a minus M group? You know, here what I said, if any lone pair containing species, if it is attached to the sp2 carbon, that it will be behave as a plus M. If lone pair absent species, if it is attached to the sp2 carbon, that it will be behave as a which one? Minus M groups, right? Now why, how the nitrogen will not have the lone pair of electron? Now we'll see. Normally the nitrogen valency electrons are good octet complete. Now here normally nitrogen, it is having the what? 5 valence electron. Now it has formed the bond with the oxygen, and this complete lone pair of electron is given to the oxygen in the form of coordinate covalent bond, and this odd electron, it has formed the bond with the benzene. It has formed the bond with the benzene. In this manner, on the nitrogen there is no any lone pair of electrons. There is no any lone pair of electrons. Done. Due to this only this nitrogen or NO2 will be behave as a minus M group. Clear? Now this NO2 will be shifted towards this, and the pi bond will be shifted toward the oxygen. Then nitrogen will get the positive charge, and that positive charge will be stabilized by this pi bond. Done. Then now how the resonating structure will be there for this one? Now we'll see. Here oxygen will get the negative charge, and here it is a coordinate covalent bond. Now here the ortho position, you will get the which charge? Positive charge. Then after that, to stabilize this positive charge, again this pi electron will be shifted here. When this pi electron are shifted towards that carbon, and this para position carbon will get the positive charge. Done. Now here the N, and here it is the oxygen will get the negative charge, and here it will get the oxygen. Done. Next, again this to stabilize this positive charge, again this pi bond will be resonated here. This pi bond will be resonated here. When this pi bond has been resonated here, then this carbon will get the positive charge. Now N, and here it is a O minus, and here it is a O. Done. Clear. Again to stabilize this carbon, oxygen will be resonated here, and this pi bond will be resonated to the ring. Clear. Again the which it will be restored, aromaticity will be now restored. Clear. Then now in this manner the resonance will be happen in the which one? In the nitrobenzene. In the nitrobenzene, resonance will be happen in this manner. Now you can see, now where you can see the electron density decreased on benzene at a ortho and para positions. Clear. If the plus same groups are attached, increase the electron density at ortho and para. Minus same groups attached, decrease the electron density at ortho and para. Clear. Now next very important, very meta position increases. Good. Many of the students they will get a mistake, or many of the students they are making the very mistake on the benzene if the plus H groups are attached. Now listen carefully. If any students are in the live, now I will just ask the questions. Now try to give me the answer for this one. See, if what is the meaning of the plus H means? Plus H is nothing but hyperconjugation. Hyperconjugation we will see, or hyperconjugation stability we will see on the basis of which one? Alpha hydrogens. Hyperconjugation stability we will see on the basis of alpha hydrogens. So how to identify the alpha hydrogens? Functional group adjacent carbon. Functional group adjacent carbon should be sp3, or else if it is not the sp3 or functional group adjacent carbons, if it has hydrogens, if the functional group adjacent carbon, if it has hydrogens, those hydrogens are called as alpha hydrogens. Clear? Those hydrogens are called as a alpha hydrogens. If more the alpha hydrogens, more will be the stability. Done. Sir, what are the functional groups, sir? Are any deficient carbon? See, this is a carbon. Carbon is a deficient. Now, this carbon, if any adjacent carbons, if it is having the hydrogens, these are the alpha hydrogens for this carbocation. Done. Next, many of the students they will get mistake, or they will do the mistake where, you know, now when the double bonded carbon, if they have given this double bonded carbon, adjacent carbons, if it is having the hydrogens, these are also alpha hydrogens. Clear? Double bonded carbon, adjacent carbon, this carbon double bond carbon, adjacent carbons, if the what? These two methyl groups containing the which one? Alpha hydrogens. Two methyl groups containing the this alpha hydrogens. See, based on this pattern only, you may get a doubt. If any carbanion, if they have given this carbanion and adjacent carbons, this carbanion if they have given, and these are the adjacent carbons. Now here we will not consider these are the alpha hydrogens. Why? Because if you alpha hydrogens, if these hydrogens want to give to this carbanion, already this carbanion is a electron excess. It will not take the alpha hydrogens. What? It will not take the alpha hydrogens. So you have to be very careful for this carbanion. These are not, for this carbanion, these two are not alpha hydrogens. These two are not the which one? Alpha hydrogens. So you have to be very careful. For this functional group, double bonded carbon, double bonded adjacent carbons are the alpha hydrogens. Now we'll see if any plus H group is on benzene, how the electron density will be increased. Now we'll see. Now the plus H group is nothing but, best example for your the plus H group is CH3. Now this is a CH3. Now this is a one plus H group. Now how it will increase the electron density on the ortho and the para positions on the benzene. Now we'll see. This hydrogen, it will show what? Non-bonding resonance. How the non-bonding resonance will be there? Now this sigma bond pair of electron will be given to this carbon, and this pi bond will be shifted towards the which one? Ortho carbon. In this manner, now it will increase the electron density at ortho position. Done. And here the carbon, and this is a hydrogen, and this is a hydrogen, and this one we call it as a non-bonding resonance. Clear? This one we call it as a non-bonding resonance. Clear? In this manner the hyperconjugation will be happened. Again this negative charge will be delocalized, and this pi bond will be shifted here, and this pi bond will be shifted here, and here it will get the negative charge, and here the what? Pi bonds. Now here the double bond, here the hydrogen, and here it is a hydrogen, and here it is a hydrogen. Then again the full resonance it will be happened. Now this pi bond will be shifted toward this carbon. Done. Now here the carbon will get the negative charge. Now here the carbon will get the which one? Negative charge, and here it is a double bond. Now here the hydrogen, and here the hydrogen, and here it is the hydrogen. Then again this negative charge will be delocalized, and this pi bond, again this hydrogen will be attached to the benzene carbon. Again the same aromatic carbon will be restored. Then in this manner, if any plus H groups are attached, the resonance will be happened. In this manner, any plus H groups are attached, the resonance will be happened. So many of the students they will make the mistake. If any plus H groups are attached, how it will increase the electron density on the benzene, they don't know. Clear? If any plus H group means, sir, how you are saying this as a plus H group? Now already I explained you very clearly. If any double bonded carbon adjacent, if the double bonded carbon, if any which one? sp3 carbon, if it is having at least one alpha hydrogen or any at least one hydrogen, those hydrogen we call it as a alpha hydrogen. You can see this is a double bonded carbon. Double bonded adjacent carbons are the alpha carbons, and it is having the hydrogens. Now here also you can see this is benzene. This is the benzene, here the one carbon, here the one carbon. This benzene and this benzene, these two are the double bonded. Double bonded adjacent carbon, which is the alpha carbon only, right? And these hydrogens are alpha hydrogens. These hydrogens are alpha hydrogens. Clear? In this manner, it has been increased the electron density on the benzene. Which one? If the any plus H group is attached on the benzene, it will increase the electron density at ortho and the para position. That's the reason this we call it as a if any plus H group, if any plus H group is attached, if any plus H group is attached on benzene, electron density increases at ortho and para positions. If any increases at ortho and para positions. That's the reason only we will call this, if any plus H groups are attached on the benzene, we will call it as a which one? Which one we will call? We will call it as a weak ring activating groups. If any lone pair containing species, if it is directly attached to the benzene, then that groups we will call it as a strong ring activating group. If any plus H groups are attached to the benzene, then we will call it as a which one? Weak ring deactivating group. Weak ring deactivating groups. Clear? Then after that, now next we are going to see, we have seen the how the minus M groups, if it is attached to the benzene, if any plus M groups are attached to the benzene, how the electron density increased and how the electron density decreased. Now we have seen. Now depending upon the different groups, how it has been classified. So many of the students, they will make the mistake and they will get confusion here itself. By giving the here, they know applications of the inductive effect, they know the applications of the inductive effect, and they know the applications of the mesomeric effect, they know the applications of the mesomeric effect, and they know the applications of the hyperconjugation. They know the applications of the hyperconjugation. But when they have given the benzene, which effect they have to consider, they don't know. Many of the students, they will get confusion and they will do the mistake here itself. Even though they know the concept of the inductive effect, mesomeric effect and the hyperconjugation, how they will do the mistake means, if for the benzene, if this is a benzene and one phenol, better well-known example for this one, phenol we will take. This phenol, due to the presence of this lone pair of electron and this benzene pi bond, both are parallel to each other, and this oxygen is a 2p and this carbon is also 2p. Delocalization or the mesomeric effect to happen, both the atoms should be in the same plane and both are the 2p. Clear? When the both are 2p, now here which effect is more dominating? Plus m effect is more dominating. Done? Then next, in the another case, what is the meaning of the inductive effect? Partial displacement of the sigma bond pair of electron towards itself is known as the inductive effect. Now you can see here this oxygen, it will displace the sigma bond pair of electrons of the, which one? Sigma bond pair of electrons of the benzene. Now in the partially, when it is displacing the sigma bond pair of electrons of the benzene, it is showing as a which effect? Minus I effect. But which effect is more dominating means, for this one, plus m effect will be more dominating for the which one? Phenol. Clear? Because lone pair of electron with the what? Complete transfer of the pi electrons is known as the mesomeric effect. This what? Phenol, oxygen lone pair of electron and this benzene pi bond. Now if you want to see with the aniline case, you can see, already I explained, this lone pair of electron and this pi bond are parallel to each other, and any delocalization to be happened, all the atoms should be in the which one? All the atoms should be in the plane and those should be parallel to each other. So due to this parallel nature only, this lone pair of electron will be given to the benzene and it increases the electron density at ortho and para positions. Done? Now next one, if suppose aniline, if they have given, this is a aniline. Now in the aniline also, this nitrogen is a 2p, this carbon is 2p. Now both are 2p. Done? It will show the plus m effect due to the 2p overlapping, and it is having the lone pair of electron and partial displacement of sigma bond pair of electron. This benzene sigma bond pair of electron will be partially displaced by the which one? Nitrogen. Due to that, it will show the minus I. But plus m effect is more dominating. Which effect is more dominating for the aniline? Plus m effect is more dominating. Next, when it comes to the anisole, this is the anisole. This is a CH3. Now here this is plus m effect and minus I effect. Plus m effect is more dominating because this is 2p and this is 2p. Done? Clear? Next, when it comes to the nitrobenzene, nitrobenzene plus m, nitrobenzene minus m and minus I. Minus m effect is more dominating. Done? Next, if suppose any, here it is very important. Clear? Here if suppose any CH3, toluene if they have given, if any ethyl benzene if they have given. Done? Next, any isopropyl benzene if they have given. Done. Now, if any tertiary carbon, if it is attached to the benzene, if suppose this type of the 4 compounds they have given and they ask which among the following having which among the following having the high plus H effect, which among the following, here the among the 1, among the 2, among the 3 and among the 4, which is having the high plus H effect, hyperconjugation effect among the 1, 2, 3, 4. If anyone is in the live, they can answer. If anyone are in the live, they can answer. Which one among the 1, 2, 3, 4, which one is having the high plus H effect? Among the 1, 2, 3, 4, which is having the high plus H effect? Plus H effect. Plus H effect. More alpha hydrogens. Then one is having the high plus H effect. Then how come the tertiary carbon, Nana? How come the fourth one will have? See, fourth one does not contain any alpha hydrogen. One will increase the electron density on the benzene very fastly and it is having the high plus H effect. See, this is having the 0 alpha hydrogens. Now you can see this is a double bonded carbon. This is a double bonded carbon. Double bonded carbon, this is a alpha carbon. Double bonded carbon, alpha carbon. Alpha carbon does not contain any hydrogen. 0 alpha hydrogen. Here this is a double bonded carbon and it is having the 1 alpha hydrogen. Now this is a double bonded carbon and it is having the 2 alpha hydrogens. Now it is a double bonded carbon. It is having the which one? It is having the which one? It is having the 3 alpha hydrogens. So among the alpha hydrogens case, the plus H effect is more for this one, right? Now here it is having the plus H effect as well as the plus I effect. Now for this toluene, plus H effect is more dominating than the plus I effect. Done. Plus H effect is more dominating than the which one? Plus I effect. Now next, if suppose acetanilide, if they have given, now this is a acetanilide. Now can anyone say the acetanilide and the phenyl acetate? Now this is a one phenyl acetate. Among the acetanilide, among the phenyl acetate, this acetanilide will show plus M effect or minus M effect. This one will show plus M effect or minus M effect. Can anyone? This one will show the plus M effect or minus M effect. This one will show plus M effect or minus M effect. This will show plus M effect or minus M effect. Plus M effect. Both plus M effect. Good. Both will show the no. First one will show plus M, nitrogen, it contains lone pair of electron. Nitrogen contains lone pair of electron, right? Due to the presence of this lone pair of electron, it will show the plus M effect, not minus M. It will show the plus M effect. Plus M effect and minus I effect due to the partial displacement. Here the oxygen lone pair of electron. Now it will show the plus M as well as minus I. Plus M effect is more dominating. Plus M effect is more dominating than the minus M effect. Done. Next, if suppose benzonitrile, if suppose the benzonitrile, if they have given, then the benzonitrile, it is having the minus M effect is more dominating than the minus I. Minus M effect is more dominating than the minus I. Clear? Next, if suppose now we'll see in which case the delocalization will be happen. If this concept is clear, Nana, for you, if this concept is clear, whatever may be the delocalization questions they may ask, it will be clear for you and you will not make any mistake. What is the one very key point you have to remember here? The very key point you have to remember that in which compound the delocalizations will be happened, in which compound the delocalization will not happen. See, first point, in the first one, any compound to show the delocalization, all the carbon atoms should be in the sp2 and it should be in the planar. Done? Then, first case, if they have given the, which one? Ethene. Here, sp2, but conjugation or resonance to be happened, for that one we are having the one sp2 carbon, all the sp2, one double bond, single bond, single bond, it should be there. But here the delocalization or resonance will not be happen in the one. Now if suppose 2, if they have given, if suppose they have given the, which one? CH. Okay, now if suppose if they have given the, which one? Here the CH3 they have given, CH3, CH double bond, CH2 if they have given. Here the, now here if here the resonance will happen or it will not happen in the 2, can anyone say? In the 2, in this 2 molecule, resonance, is it possible or it will not possible? Is the resonance is possible or not possible in the 2? In the 2 molecule, is the resonance is possible or not possible? Is it possible or it is not possible? In the molecule number 2, clear, propene, prop 1 in the prop 1 resonance is possible or it is not possible? Prop 1 no, possible kaado. How come it will be possible? Conjugation. I am asking conjugation. Conjugation adutunana. Conjugation possible kaadu. Conjugation means this is a conjugation, right? Here the pi bond should be shift. Here this is conjugation. Now here how come this conjugation is possible? Here you can see, if this pi bond, if it is want to shift toward this carbon, if this conjugation, if it is want to happen here, this carbon is sp3. No conjugation. This carbon is sp3. Then if this carbon is sp3, then all the p orbitals are filled. sp3, how? Delocalization. All the p orbitals will be filled, right? Now all the p orbital is filled means this pi electrons will not accepted by this sp3 carbon. So no conjugation. That's the reason I am saying you, in which compound the conjugation will happen, which compound the conjugation or delocalization will not happen. That if it is clear for you, now in the application part you will not get any mistake. Then second, now in the third one we'll see. Third one, here this is a CH3. Now here the CH, double bond CH, and here it is the CH3. Now will the conjugation will be happen in this compound? Will the conjugation will be happen in this compound? Third one. Will the conjugation is possible for this compound? Will the conjugation is possible for this compound? Will the conjugation is possible for this compound? Third one. Is it possible or it is not possible? Is the conjugation is possible or not for this third one? No, because these are sp3 carbons. No, good. These are sp3 carbons. sp3 carbons. sp3 carbons, no conjugation is possible. There is no any conjugation because this pi bond cannot be shift to here because both are sp3 carbons. Now, fourth one. Fourth molecule. Now here the conjugation is possible because now this pi bond can be shifted here and this pi bond can be shifted here. Now the conjugation is possible in this case. Here the negative and here it is a positive. Conjugation can be possible here. Next, fifth one. If suppose they have given the, which one? Cumulative diene. Now if suppose the cumulative diene if they have given, in the cumulative diene is the conjugation is possible? In the cumulative diene is the conjugation is possible? In the cumulative diene is the conjugation is possible? In the cumulative diene, is the conjugation is possible? In the cumulative diene, if they are given, no, even number of double bond, even number of the double bonds if they have given, conjugation not possible, conjugation is not possible. Done. If suppose, no, good, if suppose, no, good. Next, if suppose if they have given CH3 bond, CH double bond, C double bond, O. Clear? If suppose if they have given in this manner, if they have given, here the conjugation is possible or not, delocalization is possible or not, here the delocalization is possible or not. In the sixth molecule, delocalization is possible or not? Now in the sixth molecule, delocalization is possible or not? Can anyone say in the sixth molecule the delocalization is possible or not? This is very, very important molecule. This is very, very important molecule. Can anyone say? If you don't know, you can give the question mark. If you don't know, you can give the question mark. I will say whether the delocalization will be happened in this or not, whether the conjugation is possible or not. If you are getting confusion means, you can give the question mark. I will say. Rest, any other? See, here also, here the even number of cumulative dienes if they are given. Okay, done. I will say, listen. If the even number of double bonds if they are given, here delocalization is not possible, we know, conjugation is not possible. But when this type of the concept, or when this oxygen is attached, now here the delocalization is possible. How? Because here this oxygen lone pair of electron and this pi bond both are parallel to each other. Both are, it will happen, no, delocalization will happen in this compound. How? Because if you, this oxygen lone pair of electron it has given, now this pi bond will be shifted toward this carbon. Now due to that, now you can see, due to that, now this carbon will get the triple bond. Now you can see, you may get a doubt. Clear? Now you can see, now this oxygen octet is completed, all the carbons octet is completed. Now all the oxygen octet is completed. Now more the number of double bonds are also there. Any compound in the resonance stability, already I explained very clearly. In the resonance stable compound, first in the resonating structure which is more stable, if you want to see, more the number of double bonds it should be there. After the more the number of double bonds, then octet. Now you see, this oxygen octet is completed, 1, 2, 3, 4, 5, 6, 7, 8, and more the number of double bonds are there. Clear? Here in this case resonance will be happened. This is very, very important molecule. Here resonance will be happened, but simple even number of cumulative diene if they have given, there the which one will not happen? Where simple alene molecule if they are given, conjugation will not happen. But oxygen, any lone pair containing species if they have given, now with the molecular model I will explain. Now listen, with the molecular model I will try to explain. Now if any confusion if it is having, that it will be very clear for you. Now let me try with the molecular model, so that whatever the confusion you are having, that it will be clear for you. Now let me try. Mm. Now, in this case, now this is a molecule, right? Mm. Now this is a molecular model. Now you see here. Ah, here let's suppose I will go with the fresh molecule. Here this is CH2 double bond C double bond O. Here, if this type of the molecule they have given, you will think that delocalization will not happen. But here the delocalization will be happen. Now how the delocalization will be happen? Now you see. Here you can see this molecule, this oxygen lone pair and this pi bond. You can see this pi bond. This oxygen lone pair, this pi bond, both are parallel to each other. Both are which to each other? Parallel to each other. If both are parallel to each other, delocalization is possible. But this carbon, you can see here, this carbon CH2, this carbon pi bond and this carbon pi bond. This is oxygen lone pair, this is oxygen lone pair. Here this carbon pi bond and this carbon pi bond are perpendicular to each other. You can see this is first carbon. First carbon pi bond is here. Now this is a second carbon pi bond is here. Both are perpendicular to each other, right? You can see very clearly. First carbon pi bond and second carbon pi bond, both are perpendicular to each other. But oxygen one lone pair and second carbon pi bond, both are parallel to each other. Both are which one? Parallel to each other, right? That's the reason only due to this parallel to each other, this delocalization will be happened. How? This oxygen lone pair of electron, this oxygen lone pair of electron will be delocalized and this pi bond will be shifted here. Due to that only, what it will happen? Now more the number of double bonds you will get and octet completed resonating structure will get. Octet complete resonating structure will get. In this manner, it is more stable. Okay, you may get confused when if suppose if they have given what even number of cumulative diene if they have given only with the simple carbons, it will not happen. But with the any lone pair containing species, if it is attached, then the delocalization will be happened. Is it clear for everyone? The one who is present in the live, it is clear for you? Or still if it is having any confusion? Still if it is having any confusion, you can say me. Again, once again I will explain. Done? No. No. Next. 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 Done. Here this is very important molecule. Delocalization will be happened. Next compound. Okay, done. Next compound if they have given. Which one? If suppose if this molecule they have given. Now for this molecule, will the delocalization will happen? Will the delocalization will be happen? For this molecule, will the delocalization will be happen? For this molecule, will the delocalization will be happen? Will the delocalization will be happen for this or not? Okay, done. Now, for this molecule, will the delocalization will be happen or not? Now, for this type of the molecule, delocalization will be happen. How come? Now, this oxygen lone pair of electron will be resonate here. Now, this pi bond will be shifted towards this carbon. Clear? The pi bond will be shifted towards this carbon. Now, here the resonance or conjugation will be happen. Resonance or the conjugation will be happen. Done. Next, very important. One type of the conjugation you have to remember, that is CH2 if any Br if they have given. Now here the conjugation will be happen or not, they will ask. Here also the conjugation will be happen. Why? Bromine, it is having the vacant orbital, that negative charge or this negative charge will be resonated and it will be stabilized to this vacant orbital due to the presence of this vacant d orbital. Now here the which one? Resonance, and it will be more stable, and it will be the more stable. Now if suppose the cation they have given, allyl cation they have given, allyl cation if they have given, now here it is a which one? One pure p orbital will be there, that it will be parallel to the pi bond, and here also the resonance will be happened. So the conjugation will be happened here also. Done. Next, if suppose pyrrole they have given, let's suppose the pyrrole they have given. Pyrrole, whether the conjugation will be happened or not, if they ask, now in the pyrrole the conjugation will be happened. But if suppose if they have given any this type of the compound, if they have given, here the delocalization will be happened or not, if they ask, here the delocalization will not be happened. Why? This is sp3 hybridized atom. sp3 hybridized atom, what? Delocalization will not be possible in the sp3 hybridized atoms. Already I explained very clearly. Done. Now here based on this one, next, here if any bridged carbon, if the any bridged carbon if it is there, now this bridged carbon is already I explained very clearly. Now when I was explaining the inductive effect, see, bridged head carbon carbocation is unstable because it will not stabilized by the adjacent groups. It will not be stabilized. Bridged carbon, it is unstable. Here also if it is pi bond is also present, here the pi bond is also present, no delocalization will be happened. Unstable. Done. Good. Done. Next, we'll move to the which one? Here we are going to see the which one? Stability. Here applications of mesomeric effect. Now we'll see from where the applications of mesomeric effect. Applications of the mesomeric effect. In the applications of the mesomeric effect, the first one we are going to see the stability of carbocation. In the stability of the carbocation, now I will write the molecules. If anyone or if any students who are in the online, they can answer. First one, this is a CH2. Next, now this is a second molecule. Now this is 2. Now this is a 3. If any students, if they are in the online, they can answer. Among the 1, 2, 3, which is a more stable carbocation? Among the 1, 2, 3, which is a more stable carbocation? Among the 1, 2, 3, which is a more stable carbocation? Among the 1, 2, 3, which is a more stable carbocation? Three. Oh, good, good. 3. Order. If they ask order, PCM, cyclopropyl methyl cation. CPM, not PCM. CPM, Nana. Cyclopropyl methyl carbocation. CPM. Now 3 greater than 2 greater than 1. 3 greater than 2 greater than 1. Now next. Oh, okay. Done. Okay, done. Now next. Next we are going to see. Okay, clear. Oh, no problem. Next type of the carbocation, now you have to say. Next type of the carbocation. This is 1. Now the 2 will be. Now this is 2. Now 3. Now 4. Now among the 1, 2, 3 stability order based on mesomeric effect and hyperconjugation. Stability order, same is the stability order based on mesomeric effect and hyperconjugation. Among the 1, 2, 3, 4. Same. Among the 1, 2, 3, 4 stability order. 1, 2, 3, 4 stability order. If anyone in the live, they can answer. Among the 1, 2, 3, 4, which is a more stable carbocation and why? On the basis of plus m, and he is asking stability of the carbocation on the basis of mesomeric effect and the hyperconjugation effect. On the basis of mesomeric effect and hyperconjugation effect, order is asking, order. Same is the order. If anyone in the live, they can say me the order. Or else you can say me among the 1, 2, 3, 4, which is a more stable carbocation on the basis of based on mesomeric effect and the hyperconjugation. On the basis of mesomeric effect and the hyperconjugation. On the basis of mesomeric effect and the hyperconjugation. Now the order is 2, 3, 4, 2, 3, 4, 1. Good. 2, 3, 4, 1. Good, Nana. Here the benzyl carbocation. All the 4 cases benzyl carbocation is no, Rishika. 2, that is 2, 3, 4, 1 is correct. Benzyl carbocation and the 3 alpha hydrogens. Benzyl carbocation, 3 alpha hydrogens. Benzyl carbocation, 2 alpha hydrogens. Done. Here benzyl carbocation is common. Benzyl carbocation is common. Here also benzyl carbocation is common. Both the cases benzyl carbocation is common. But here the no plus I effect. No plus I effect. But here plus I effect is there, right? In the fourth case plus I effect is there. But in the first case no plus I effect. So the order will be 2 greater than, 3 greater than, 4 greater than 1. This will be the order. This will be the order. Clear, right? Next one. Next one, NO2, first one. Now second one we are having CN plus. Third one we are having CNF. And fourth one we are having CN. Among the 1, 2, 3, 4, which is a more stable carbocation? Among the 1, 2, 3, 4, which is a more stable carbocation? Among the 1, 2, 3, 4, which is a more stable carbocation? Among the 1, 2, 3, 4, which is a more stable carbocation? Among the 1, 2, 3, 4, which is a more stable carbocation? 4. Good, Nana. 4 is a more stable carbocation. 4 is more. Then after that, next order. If they ask the order mean order. Order if they ask. Order if they ask, which is a more stable carbocation? Order if they ask, which is a more stable? 4, 3, 4, 3, 4, 3, 2, 1. Correct? 4, 3, 2, 1. Correct? 4, 3, 2, 1. 4, 3, 2, 1 is a correct one. Why? Because minus I effect. In all the cases, allylic position is same. Allyl carbocation is same. In all the positions, which one? Allyl carbocation is same. Now minus I effect order. Minus I effect order. NO2 is greater, right? Then CN. Then after fluorine. Then after chlorine. This is a minus I effect order. Okay? Next one. Next one. Very interesting question. Now try to give the answer here. Next the carbocation. Now next, this is 1. Now this is 2. Now 3 we are having. Now you see. Now among the 1, 2, 3, which is a more stable carbocation? Among the 1, 2, 3, which is a more stable carbocation? Among the 1, 2, 3, which is a more stable carbocation? Among the 1, 2, 3, which is a more stable carbocation? Among the 1, 2, 3, which is a more stable carbocation? 2. How come 2, Amma? How come 2? How come 2? How come 2 is more stable? My question for you is how you are saying that 2 is more stable? Pranit, how you are saying that 2 is more stable, Anna? 1 is more stable. See, here resonance is happening for the 1. Here also resonance is happening for the 2. Both the cases resonance is same. But in the 1 we are having the 2 alpha hydrogens. But in the 1 we are having the 2 alpha hydrogens. But in the which one? But in the 2 we are having only 1 alpha hydrogen. So the 1 is more stable. I thought rearrangement. Rearrangement. No, without rearrangement. Here just see, whenever the carbocation stability order, if they ask, you should not do any rearrangement and all. If after the rearrangement, if they ask the stability, means they will provide the After the rearrangement, try to give the stability order. They will mention in the question very carefully. If they have not mentioned any rearrangement, means normal given molecule carbocation stability order you have to find. That's it. Okay. 1 greater than 2 greater than 3. Now the whatever the molecule I was writing, for that one you have to say the correct which one stability order with the reason. The first one. Now the first, this is a one carbocation. Now these are the 4 carbocations we are having. Now the normal 4 carbocations we are having. Now better here one carbocation. Done. Here the one carbocation. Now here the one carbocation. Done. Now here the ortho position CH3, meta position CH3, para position CH3 and normal. 1, 2, 3, 4. Now semi. Among the 1, 2, 3, 4, which is a more stable carbocation and order? Among the 1, 2, 3, 4, which is a more stable carbocation and order? Among the 1, 2, 3, 4, which is a more stable carbocation and the order? Order also you have to say me. 1, 2, 3, 4, which is a more stable carbocation and say me the order. Which is a more stable carbocation and the order? 1, 3, 2, 4. Good. Good, Nana. Good. 1, 3, 2, 4. Because here this is a plus H effect. Here it is a plus H effect. Here it is a plus I effect. Clear? Plus H effect is more dominating. Then after that, hyperconjugation 1 and 3 and inductive effect in 2. Good. 1 greater than, 3 greater than, 2 greater than 4. So 1 greater than 2, 3 greater than, 2 greater than 4. Good. Now, next. Next, here also you have to be very careful. Here carbocation. Here the OH. Next. Now here the carbocation. Here the OH. Now here the carbocation. Now here the OH. Here the carbocation. Here the carbocation. Normal. Okay. Now you say me the order. Now in this one, order 1, 2, 3, 4. 1, 2, 3, 4. Say me the order. Say me the order for this one. Order for the 1, 2, 3, 4. Order. What is the order for this one? Among the 1, 2, 3, 4, which is the order? 1, 3, 4, 2. Good. No. 1, 3, 4, 2. Because here it is a plus M effect. Here the plus M effect. And here it is a minus I effect. And this is a normal. So the order will be 1 greater than, 3 greater than, 4 greater than 2. 1 greater than, 3 greater than, 4 greater than 2. Clear. Good. Nana. Good. 1 greater than, 3 greater than, 4 greater than 2. Good. Done. Next. If suppose if they have given on carbanion. Now stability of the carbanion we will check. Now, stability of the carbon. Now we'll see stability of in the stability of the carbanion. In the stability of the carbanion, we know here if suppose any carbanion, if they have given here, it is a fluorine 1. Now how the stability of the carbanion will be explained? Now you can see here in the stability of the carbanion, if suppose the stability of the carbanion, here the F and here the fluorine, done. Second one, here the F and here it is a NO2. Now the third, here it is a F and here it is a CN and it is a 4, here the F and here it is a normal will take. Now among the 1, 2, 3, 4, which is a more stable carbanion? Which is a more stable carbanion? Which is a more stable carbanion? 2, 3, 1, 4. Good, Nara. 2, 3, 1, 4. 2, 3, 1, 4 will be the more stable carbanion. Done. Now. I forgot the one question to say. One question to say among the carbocation. I forgot. Now listen. If suppose they have given this one. Here the 1 CH3, this is 1. Now here they have given normally OH they have given. Okay, this is 2. Now 3 they have given. Here here the cation they have given. Let assume here they have given the one NO2. Now fourth they have given normal. Here the NO2 they have given. Now here the NO2 they have given. Now better we'll take this one. Here here the O, here the OH. Among the 1, 2, 3, 4, among the 1, 2, 3, 4, which is a more stable carbocation? Stability of carbocation. Among the 1, 2, 3, 4. Among the 1, 2, 3, 4. Among the 1, 2, 3, 4, which is a more stable carbocation? Among the 1, 2, 3, 4, which is a more stable carbocation? If anyone are in the live, they can say if which is a more stable carbocation. Among the 1, 2, 3, 4, which is a more stable carbocation? Tilida. Now listen. Clear? I will explain very clearly with the molecular model. Now you listen. Among this one, here the order will be 1 greater than 4 greater than 1 greater than 4 greater than 3 greater than 2. 1 greater than 4 greater than 3 greater than 2. No, it is not the which one? This is very important molecule. Repeatedly they are asking in the JE. See here why it has become the one. You may get a doubt. Sir, here the OH is there. OH will having the lone pair of electron. It can stabilize the carbocation very fastly. Carbocation, it can stabilize the very fastly. You may consider and you may think. Now listen. So why it is having the unstable with the molecular model, I will explain. Now listen carefully. Here you can see here whatever the cation it has formed, This is a benzene, right? This is a benzene. Now benzene position, which one is attached? One OH is attached. How the OH is attached? One minute. Now, done. Here, what it is there? Now, this is a benzene. This is a benzene. For this benzene, here it is a cation. For this benzene, here it is a cation. Now, this cation for this benzene, whatever the cation that benzene it has got, by the loss of this, which one? Sigma bond pair of electron. This sigma bond pair of electron it has lost. Now, this is a which one? This is a empty orbital. This is a which one? Empty orbital. Empty orbital of this carbon. This carbon empty orbital, this one. This carbon empty orbital. Now, here the group attached here, it is a which one? Already this pi bond, we know p orbital. In this manner the p orbital will be there, right? P orbital will be there in this manner. Already this pi bonded electron, this oxygen lone pair of electron, you can see this oxygen lone pair of electron, ఈ ఆక్సిజన్ లోన్ పేర్ ఆఫ్ ఎలక్ట్రాన్ ఉంది కదా, ఈ ఆక్సిజన్ లోన్ పేర్ ఆఫ్ ఎలక్ట్రాన్ ఏదైతే ఉందో ఆల్రెడీ ఇట్ హ్యాస్ బీన్ ప్యారలల్ విత్ ద విచ్ వన్? విత్ బెంజీన్ పై బాండ్. యూ కెన్ సీ ఇన్ దిస్ వన్. దిస్ ఆక్సిజన్ లోన్ పేర్ ఆఫ్ ఎలక్ట్రాన్ అండ్ దిస్ బెంజీన్ పై బాండ్ ఆర్ ప్యారలల్ టు ఈచ్ అదర్. నౌ దిస్ వేకెంట్ p ఆర్బిటాల్ యూ కెన్ సీ హియర్. ఈ వేకెంట్ p ఆర్బిటాల్ ఏదైతే ఉందో ఈ వేకెంట్ p ఆర్బిటాల్ ఈ ఆక్సిజన్ లోన్ పేర్ ఆఫ్ ఎలక్ట్రాన్ ప్యారలల్ లో ఉన్నాయా, పర్పెండిక్యులర్ లో ఉన్నాయా? యూ కెన్ సీ ఇన్ దిస్ మేనర్. యూ కెన్ సీ in this manner also you can see this oxygen lone pair of electron. Now whatever the carbon, this carbon positive charge vacant orbital ide kada, carbon oxygen vacant orbital, ee carbon oxygen vacant orbital and this oxygen lone pair of electron, both are perpendicular to each other, right? Both are perpendicular to each other. When the both are perpendicular to each other, how this oxygen lone pair of electron will stabilize this positive charge? Perpendicular lo unnai kadamma, పర్పెండిక్యులర్ లో ఉన్నాయి కాబట్టి దిస్ ఆక్సిజన్ లోన్ పేర్ ఆఫ్ ఎలక్ట్రాన్, వై ఇట్ విల్ బి స్టెబిలైజ్ దిస్ కార్బోకేటయాన్? డీలోకలైజేషన్ విల్ బి హ్యాపెన్. ఈజ్ ఇట్ ఎనీ ఛాన్స్ టు హ్యాపెన్ ద డీలోకలైజేషన్? మీరే చూడండి, ఇప్పుడు ఇక్కడ OH ఉంది, ఈ ఆక్సిజన్ లోన్ పేర్ ఆఫ్ ఎలక్ట్రాన్, దిస్ ఆక్సిజన్ లోన్ పేర్ ఆఫ్ ఎలక్ట్రాన్స్ యూ మే థింక్ దట్ ఇట్ విల్ స్టెబిలైజ్ దిస్ విచ్ వన్? వేకెంట్ ఆర్బిటాల్ ఆఫ్ దిస్ కార్బన్, బట్ దీస్ ఆర్ పర్పెండిక్యులర్ టు ఈచ్ అదర్. అండ్ నెక్స్ట్ యూ కెన్ సీ దిస్ వన్ వేకెంట్ p ఆర్బిటాల్ and this pi orbital, this pi bond, both are also perpendicular to each other. ఇక్కడ కూడా చూడండి, ఇట్లా కూడా చూడండి, రెండు పర్పెండిక్యులర్ లో ఉన్నాయి కదా, అంటే బెంజీన్ యొక్క పై బాండ్ ఎలక్ట్రాన్స్ కూడా దీన్ని స్టెబిలైజ్ చేస్తలేదు. సేమ్ థింగ్ దిస్ ఆక్సిజన్ OH గ్రూప్ కంటైనింగ్ ఆక్సిజన్ లోన్ పేర్ ఆఫ్ ఎలక్ట్రాన్ కూడా ఈ వేకెంట్ p ఆర్బిటల్ ని స్టెబిలైజ్ చేస్తలేదు. when they are not stabilizing, then which effect is present here? There is no any. If the OH here, the for this OH here the plus m effect is absent. Which effect is absent? Plus m effect is absent. Now which effect will be more dominating for this one? Now minus I effect will be more dominating. Minus I effect will be the more dominating and the plus m effect will be what? Due to the when the delocalization is absent, plus m effect is absent, right? Now you see, that's the reason here what it will happen? Plus m effect is absent and minus I effect will be present. Here also plus m effect is absent. Sorry, here the plus m effect will not be there if you consider, and here the minus I, and here also plus m effect is not present, only the minus I. Clear? Now you can see minus I is far away from them. Minus I is far away from them, so more stable. This is CH3. Due to the inductive effect will be there, right? CH3 will be the inductive. Due to the inductive effect, it will pull the electrons towards itself. Clear? Now this OH, it will pull the electrons towards itself due to the minus I. but with the plus M it is not able to give. Done? Clear? That's the reason 1432. This is very, very important molecule. Very, 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 very important. So you have to be very careful. If the benzene carbon directly, if it is having the positive charge, plus M effect is not considered. Only the minus I effect of the benzene will be considered. Only the minus I effect of the benzene will be considered. Then only the which effect of the benzene is considered? Only the minus I effect of the benzene is considered. Next. Okay. Now the next in the carbanion case we'll move. In the carbanion case, if suppose they have given this carbanion 1 and the next carbanion, here the negative charge, and if suppose sulfur they have given here the sulfur, and here it is a carbanion. Among the 1, 2, 3, which is a more stable carbanion? Can anyone? Which is a more stable carbanion? Among the 1, 2, 3, which is a more stable carbanion? Which is a more stable carbanion? Among the 1, 2, 3, which is a more stable carbanion? No, no, not the 2. Not the 2. 3 is more stable carbon. In the 2, this negative charge delocalization will not be happen. In the 2, negative charge delocalization will not be happened. Why? Why the negative charge delocalization will not be happened? Because this oxygen vacant orbital is absent. Oxygen vacant orbital is absent. Due to the oxygen vacant orbital is absent, now the sulfur, due to the presence of vacant d orbital, this negative charge will be delocalized. No empty orbital, but only due to the electronegative, more due to the electronegative, it will stabilize this carbanion. So this is here there is no any electronegative element. So the answer will be 3 greater than 2 greater than 1. 3 greater than 2 greater than 1. This is very, very important. Next, if suppose CF3 CH2 minus, if they have given, this is 1. Next, CCl3 CH2 minus, if they have given, this is 2. Among the 1 and 2, which is a more stable carbanion? Which is a more stable carbanion? Which is a more stable carbanion among the 1, 2, among the 1 and 2? 2, because here the chlorine, due to the vacant p orbital, due to the presence of this vacant p orbital, this negative charge will be delocalized. Negative charge will be delocalized very fastly. Then here the 2 greater than 1. 2 greater than 1. Now next, here next, acidic nature. Now acidic nature of the phenol. First we'll study about the acidic nature of the phenol. Amma, should I end the class here, or you are ready to listen? Will you listen the class? If you want to listen the class, I will continue. If not, I will wind up here. If you want to listen the class, I will continue. Okay, done. Phenols, listen now whatever the concept I was explaining, that it is very, very important. If you are having a luck, you may get the one question from among these 3 concepts. Okay, 3 concepts. What are the 3 concepts? What are the 3 concepts we are going to study? One is acidic nature of phenol, One is acidic nature of the benzoic acid, one is basic nature. I will explain very clearly with the n number of examples. Now you listen. First is a which one? Acidic nature of phenol. Acidic natures of the phenol. Now in the acidic natures of the phenol, first one, whenever the already I explained very clearly, whenever the phenol they have given, then phenol acidic nature will be checked on the basis of stability of its conjugate base. Now this is a conjugate base of phenol. This is the conjugate base of the phenol, right? Now this conjugate base, if it is stabilized fastly, if this conjugate base is stabilized very fastly, then that given compound is a more acidic. Clear? Now acidic nature of the phenol means phenol acidic nature is depend on stability of its conjugate base. Clear? Now phenol conjugate base stability order. Phenol conjugate base stability is first minus M. Minus M will be stabilize that conjugate base. Next minus H. Next minus I. Next plus H plus I. Next plus H. Last will be the minus M. This is the order. For the stability of that conjugate base. Clear? Now we'll see. Here, first one, if normally alcohol if you take and phenol if you take. Now both the cases the conjugate bases are here the RO minus. Now here the conjugate base is, for this one the conjugate base is O minus. Here among these two which is a more acidic if they ask. Now phenol is a more acidic, we know, because this conjugate base is stabilizing by the resonance, but its conjugate base due to the plus I group, its oxygen electron density again it will be increased and its conjugate base stability will be decreased. Done? Clear? Now if suppose on the phenol, this is a phenol. Now ortho position one methoxy group it is there. Now this is a phenol. Now this is a meta position. This is 1, this is 2. Now this is OH and this para position one methoxy and the normal one phenol. Now among the 1, 2, 3, 4 which is a more acidic? Among the 1, 2, 3, 4 which is a more acidic? Among the 1, 2, 3, 4 which is a more acidic? Among the 1, 2, 3, 4 which is a more acidic? Among the 1, 2, 3, 4 which is a more acidic? Four. No, Nana. No, Praneeth, once again you cross check. Answer is not the 4. Answer is not the 4. Answer is not the 4. అవును మిథాక్సి ప్లస్ ఎంఏ కానీ అక్కడ 4 మాలిక్యూల్స్ ఉన్నాయి. కానీ 4 మాలిక్యూల్స్ ఉన్నాయి. నీకు కాంజుగేట్ బేస్ని ఏది స్టేబుల్ చేస్తుంది? ఇక్కడ హైడ్రోజన్లు తీసేయి, ఇక్కడ నెగిటివ్, ఇక్కడ నెగిటివ్, ఇక్కడ నెగిటివ్, ఇక్కడ నెగిటివ్. అమాంగ్ ద 1 2 3 4 ఏది తొందరగా స్టేబుల్ అవుతుంది? తెలిస్తే రీజన్ చెప్పు, తెలియకపోతే ఇఫ్ యూ డోంట్ నో గివ్ మీ ద క్వశ్చన్ మార్క్. ఐ విల్ ఎక్స్ప్లెయిన్. తెలిస్తే క్వశ్చన్ మార్క్ రీజన్ చెప్పు, తెలియకపోతే క్వశ్చన్ మార్క్ ఇవ్వు. If you don't know, give me the question mark. Yet in the second position, here the plus m and the minus I. Here the plus m and the minus I. Here the minus I is more dominating for the mesoxy at the which position? Meta position, right? Meta position OCH3 will be act as the minus I. Minus I effect is more dominating. Minus I effect is more dominating. Here the plus m and minus I. Here the plus m effect is more dominating. Here also plus m minus I. Plus m effect is more dominating. Then 2 will be stabilize this conjugate base very fastly, right? So 2 is more. Then 4. Then 3. Then 1. This will be the order. This will be the order. Clear? This will be the order. Nice. Next question I will give. Next question you try to do. Next question, try to give the answer carefully. Now which effect will be dominates over there and which one will be stabilized, that all you have to cross check. Okay, normal phenol. Now second one, CH3. Now third one, OH. Here the here it is a CH3. Among the 1 2 3 4 among the 1 2 3 4 among the 1 2 3 4 try to say me the answer. Among the 1 2 3 4 try to say me the answer. Among the 1 2 3 4 try to say me the answer. Among the 1 2 3 4 try to say me the answer. One 3 4 2. Good. 1 normal. So 1 3 4 2. Now one very interesting question I will ask you. Try to apply your all the concept and try to give me the correct answer. Okay. Now first one resorcinol I was taking. This is one resorcinol. Okay. Next one catechol I was taking. One catechol. Done. Next one hydroquinone I was taking, or quinol I was taking. Normal phenol I was taking. Normal phenol I was taking. Now among the 1 2 3 4, among the 1 2 3 4, which is the more stable or which is the more acidic? Now you say acidic strength order. Acidic strength order. Among the 1 2 3 4 acidic strength order. acidic strength order. 1, 4, 3, 2 కాదు. No. No. Not 1, 4, 3, 2. Not 1, 4, 3, 2. Oh, one is more acidic. Okay, that is okay for that one. One is more acidic. But among the no. Once you try, affect all the effects. 1, 3, 4, 2. That is also not correct. 1, 3, 2, sir. 2 is more acidic. 2 is more acidic. No. అట్లా ఏం లేదు. అట్లా no. ప్లేనారిటీ లాస్ట్ అయితే ఆ OH మైనస్ స్టెబిలిటీ రాదు. ప్లేనారిటీ లాస్ట్ అయితే స్టెబిలిటీ రాదు. ప్లేనారిటీ లాస్ట్ అయితే అట్లా రాదు కదా నాన్న. సో ట్రై చేయండి, మళ్ళా ట్రై చేయండి, అన్ని ఎఫెక్ట్స్ చూడండి. తెలీదా? షుడ్ ఐ సే? Now here first this is minus I effect. This is minus I effect. Okay, this is minus I effect. But here due to the presence of hydrogen bonding, it is stabilize the phenoxide ion. ఈ 2లో హైడ్రోజన్ బాండింగ్ ఉంటుంది. క్లియర్? దిస్ ఈస్ నార్మల్ మైనస్ ఐ ఎఫెక్ట్. one is more acidic. Then after that in the 2 we may think that here it is having the more plus m effect than the minus I. But due to the presence of this hydrogen bonding, what happens? Its minus I effect will be more dominating than the plus m. Minus I effect will be more dominating than the which one? Due to the resonance compared to this acidic strength, this one it is having less. Why? Because here the plus m is there and here the hydrogen bonding will be there. Due to that next order will be 2, but here it will be the plus m and minus I. Plus m will be the more dominating and the normal will be 4 and the last will be 3. This is very important molecule. Now you have to be very clear. ఇక్కడ హైడ్రోజన్ బాండింగ్ ఉంటుందన్న. హైడ్రోజన్ బాండింగ్ ఉండడం వల్ల అదేమవుతుంది? ఫీనాక్సైడ్ అయాన్ స్టెబిలిటీ అవుతుంది. ఓకే, when the 2 hydroxyl group it is present on the ortho position, what will happen? Electron withdrawing effect further stabilize the negative charge on the phenoxide ion. ఇక్కడ మెసోమెరిక్ ఎఫెక్ట్ డామినేటింగ్ గా ఉండదు. ఆ మెసోమెరిక్ ఎఫెక్ట్ డామినేటింగ్ గా ఉండదు, కానీ మైనస్ ఐ ఎఫెక్టే డామినేట్ చేస్తుంది హైడ్రోజన్ బాండింగ్ వల్ల, విచ్ స్టెబిలైజ్ ద ఫీనాక్సైడ్ అయాన్. క్లియర్, రైట్? సో ఇది ఆర్డర్, ఇంపార్టెంట్ మాలిక్యూల్ ఇది. యూ హ్యావ్ టు బి వెరీ క్లియర్ విత్ దిస్ టైప్ ఆఫ్ ద మాలిక్యూల్. నెక్స్ట్ ఇంకొక మాలిక్యూల్ రాస్తా, చెప్పండి. ఇప్పుడు okay, this is one. ఇక్కడ Cl, ikkada the OH. Next done, here the normal OH. Next next will be the, here the CH3, here it will be the OH. Okay, now here it will be the OCH3 and here it will be the OH. Now 1 2 3 4 5. Acidic strength order. Acidic strength order. Acidic strength order. 1 2 3 4 5. Good. 1 greater than, 2 greater than, 3 greater than, 4 greater than 5. 1 greater than, 2 greater than, 3 greater than 5. Next, normal. If suppose next, if suppose if they have given this one, phenol they have given. Okay, now just you try, if you know, you say me the answer. If suppose if they have given 1 2 3, now if suppose the 1 2 3 if they have given, which is more acidic? Which is more acidic? Which is more acidic? Which is more acidic? Which is the more acidic here? Among the 1 2 3, which is the more acidic? Telida? Whenever, blindly believe, among the phenol and the carboxylic acid functional group, if it is same, whatever it may be, the carboxylic acid functional group is a what? Carboxylic acid is a high acidic. Done. Now the answer is 1 greater than, 2 greater than, 3. Clear? Here the carboxylic functional group it is there, right? Now in this carboxylic acid functional group, now this negative charge will be stabilized in the cross conjugation. Done. Here the this oxygen negative charge, here it will be stabilized, but in the carboxylic acid case it is more stable and it will be given the hydrogen very fastly. Whenever the carboxylic acid and whenever the phenol competition comes, carboxylic acid is a high acidic. So you have to be very careful with this one. Done. Now next we'll move to the stability order of, or stability of, or acidic strength of, we can see with the acidic strength, acidic strength of carboxylic acids or benzoic acid. Acidic strength of benzoic acids. Now we'll see. In the benzoic acid already we know ortho substituted benzoic acid. We know ortho substituted, ortho, any ortho substituted benzoic acid. Ortho substituted, or else you can write ortho group containing, ortho group containing benzoic acid is more acidic. Ortho group containing benzoic acid is a more acidic. Why? Because carboxylic acid, because the carboxylic acid will become perpendicular to the benzene. It will become the perpendicular to the benzene, and that carbonyl group will be stabilized. This carbonyl group will stabilize very fastly. Will stabilize very fastly. Clear? Now this is about the ortho effect. Now if suppose normal formic acid if they have given. Next to benzoic acid if they have given. Benzoic acid if they have given. Formic acid if they have given, benzoic acid if they have given, normal acetic acid if they have given. Now which is a more acidic among the 1, 2, 3? Among the 1, 2, 3, which is a more acidic? Among the 1, 2, 3, which is a more acidic? Among the 1, 2, 3, which is more acidic? Which is a more acidic among the 1, 2, 3? Among the 1, 2, 3, which is more acidic? Among the 1, 2, 3, which is more acidic? Among the 1, 2, 3, which is more acidic? 2, 1, 3. కాదు నాన్న, కాదు. It is not 2, 1, 3. It is not the 2, 1, 3. It is not the 2. It is not the 2, 1, 3. It is not the 2, 1, 3. Now the answer is 1 greater than 2 greater than 3. Why? Because here this is a which one? Normal hydrogen. This is a normal hydrogen, but here it is a plus I. Here it is a plus I. Now here among the, this is very stabilized very fastly. This one will stabilize. No, not 3, 1, 2. Answer is 1, 2, 3. Not 3, 1, 2. Amma. See here this conjugate acids conjugate bases should be stabilized kada. Acids conjugate base should be stabilized. This conjugate base will be the this manner. This is a conjugate base. Now what is the conjugate base of this one? This is a conjugate base of this one. Now what is the conjugate base of this one? Now this is a conjugate base of this one. Now you see, to stabilize this conjugate base, it will be stabilized very fastly because this is a hydrogen. Hydrogen will not give any electron pair of donor to the carbonyl carbon. Now this conjugate base is stabilizing to the resonance. But when it comes to here, this is stabilizing, but here the plus I group is there. Here the plus I group is there. But you may get a doubt, sir, here the benzene is also giving the plus M effect to the carbonyl carbon. Here you may get a doubt, sir, here it is a plus H effect is there, but here it is a plus M effect it is there of the benzene. When the plus M effect of the benzene, if it is present, now you can see very carefully here what, here this carbonyl carbon is attached to the sp2 carbon. Here this carbonyl carbon is attached to the sp3 carbon. In that manner we can justify. Here it is attached to the sp3 carbon, here it is attached to the sp2 carbon. Here it is a normally free, so this one will be stabilized very fastly. So one is more acidic. Then after that, among the two, it is attached to the sp2 carbon, it is attached to the sp3 carbon. We know percentage S character increases, electronegativity increases. In the sp2 electronegativity will be more and it will be stabilized very fastly. Here the sp3 carbon percentage S character will be less and the electronegativity will be less. So that is the acidic strength order will be 1 greater than 2 greater than 3. In this manner you have to cross check. Clear? Clear? Now the order will be 1 greater than 2 greater than 3. Now we know the ortho substituted benzoic acid will be the more acidic, that we know. Next, if suppose if they have given this one, if they have given in this manner, If suppose 1 greater than 2 greater than 3, if they have given 1 greater than 2 greater than, or sorry, 1 2 3, if they have given, among the 1 2 3, which is more acidic, which is a more acidic among the 1 2 3, among the 1 2 3, which is more acidic? Among the 1 to 3, which is more acidic? 3 to 1. Good. Because more the bulky on the ortho position, more will be the acidic. More the bulky on the ortho position, more will be the acidic. Done. Next. Second. COH, here the fluorine. COH, here the Cl. COH, here the Br. Now you say me among the 1, 2, 3. Now you say me among the 1 to 3, which is the more acidic? Among the 1 to 3, which is more acidic? Rahul. Good, Nana. Why? May I know the reason why you are saying it as a 3 to 1? Rahul, may I know the reason why you are saying it is a 3 to 1? Bulky. Good. Bromine being the bulky. Now it will be the 3 greater than, 2 greater than. Halogens are the, among the halogens, top to bottom if you move. Now top to bottom if you move, what it will happen? Now bulkiness will be increased. No. Answer is 3 to 1 only. Correct only. 3 to 1 is only. But I asked the reason. That's it. Because bulkiness at the ortho position, bulkiness increases, acidic nature increases. Answer is. Now next one. If suppose for the benzoic acid, if suppose in the benzoic acid, now any amine group if it is attached, if any amine group is attached, COOH, and here it is a NH2. Now normal benzoic acid, and here it is a COH, and here it is a para position. Now among the 1, 2, 3, 4, which is a more acidic order? 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 Among the 1, 2, 3, 4, more acidic strength order. More acidic strength order among the 1, 2, 3, 4. Among the 1, 2, 3, 4, more acidic strength order. 1, 3, 4, 2. How come 1, 3, 4, 2, Nana? Pranit, once again you cross check. Once again you cross check. 1, 3, 4, 2, 1, 3, 4, 2. 1, 3, 4, 2 కాదు. Not the 1, 3, 4, 2. Not the 1, 3, 4, 2. 1, 3, 4, 2 కాదు. 1, 3, 4, 2 కాదు. See, this is ortho effect, more acidic. Then here it is a plus M effect, NH2, right, amine. Due to the presence of lone pair effect, plus M effect is more dominating. Now this is neutral. This is neutral. But here this is minus I effect, right? NH2. Minus I effect will be there, right? NH2. Then so 1 greater than, 4 greater than, 3 greater than 2. 1 greater than 4 greater than 3 greater than 2. Clear? Next. Here normal carboxylic acid if they have given, and if suppose sulfonic acid if they have given, among the 1 and 2 which is more acidic? Meta position, it is in the meta position, right? See, for this benzoic acid it is in the meta position. Meta position minus I effect only. Among the 1 and 2, among the 1 and 2, which is the more acidic among the 1 and 2? Among the 1 and 2, which is more acidic? Among the 1 and 2, which is more acidic? Among the 1 and 2, which is more acidic? Among the 1 and 2, which is more acidic? Among the 1 and 2, which is more acidic, and why? Among the 1 and 2, which is more acidic, Nana? Among the 1 and 2, 2 is more acidic. Why? Because this oxygen can be stabilized by the 2 more electronegative atoms, and it can be stabilized with the which one? 2 more electronegative oxygens. So among this 1 and 2, this is more acidic. 2 is more acidic. Okay. Next one, if suppose benzoic acid if they have given, this is benzoic acid. Okay. Now for this benzoic acid, now the instead of hydrogen, deuterium is attached. Deuterium is attached. Among the 1 and 2, which is more acidic? Among the 1 and 2, which is more acidic, they will ask. This is also one very interesting and very important molecule. Very interesting and a very important molecule. This is also one very interesting and the important one. Among the 1 and 2, which is more acidic? Among the 1 and 2, which is more acidic? Among the 1 and 2, which is more acidic? Among the 1 and 2, which is more acidic? If you know, you can say the answer. If not, I said you right. Try to give the question mark over there. I will say the answer. Should I say the answer? Should I say the answer, or will you try? Among the 1 and 2, which is more acidic? Now among the 1 and 2, 1 is more acidic than the 2. Why? Because 1 is more acidic. You know, Rana, this oxygen and the hydrogen, and oxygen and the deuterium, this bond strength is high. Bond strength is high means this deuterium will not be given to the which one? Solution very quickly. Here the hydrogen bond strength is less. Due to the bond strength, this hydrogen will be given very fastly. That's it. This is depend upon the which one? Bond strength. Based on the bond strength, we have to decide the which is more acidic. Which is more acidic. Done? Next. See, many of the students, they will make the mistake in this compound. In which type of the compound they will make the mistake, you know? They will give you in this manner one molecule they will give you, and the second molecule they have given this one, and among the 1 and among the 2, among the 1 and among the 2, among the 1 and among the 2, and another molecule Hmm. Right. Among the 1, 2, 3, which is more acidic? This is very, very important. Among the 1, 2, 3, which is more acidic? Same molecule they will give you and they will ask you. Among the 1, 2, 3, which is a more acidic? Among the 1, 2, 3, which is a more acidic? Among the 1 and 2, which is more acidic? If you know, give me the answer. If not, give me the question mark. I will explain. 3. Then after that, 3 is more acidic. Then after that, after the 3, 3 is more acidic. Okay. After the 3. Why, Rishika, why the 3 is more acidic? No, 2 is least acidic. No, not 3 to 1. Not 3 to 1. Not 3 to 1. Not 3 to 1. Now I will explain. Now listen. Whenever this type of the compounds they have given, acidic strength will be, what I said, acidic strength will be depend upon the conjugate base stability, right? Here, if this, here the 2 hydrogens we are having, here the 2 hydrogens we are having, here the 2 hydrogens we are having. Acidic strength questions if they have given, what you have to cross check? Aromaticity. Very good, very good. Clear? This hydrogen, if it is given to the solution, means now its conjugate base will be aromatic compound. Now this conjugate base will be the which one? Aromatic compound. So this one is a more acidic. But when this conjugate base, when it has formed the conjugate base, it is getting anti-aromatic. It is getting the anti-aromatic. But in this case also, its conjugate base is getting aromaticity. But among the 1 aromaticity and the 2 aromaticity, sorry, among the 1 and 3 aromaticity, 3 is more. 3 is more stable due to the resonance. This negative charge is stabilizing by the resonance. Total 3 pi electrons. Okay. Now the answer will be 3 greater than 1 greater than 2. This is the more acidic strength. Many of the students, they will get confused whenever this type of the molecule they have given. If they ask the stability order, or if they ask which among the following is a more acidic acid, if they ask, they will get confused. They will get confused. So which one will be the more acidic? Sir, there is no any alcohol, there is no any carboxylic acid. So whenever the acidic strength questions if they have given, blindly you have to believe that you have to see the stability of its conjugate base. Stability of its conjugate base you have to cross check and you have to say. Done? Stability of the which one? Conjugate base you have to cross check and you have to say. Next one. Next very one important molecule I will write and you have to say me which among the following is a more acidic. Which among the following is a more acidic? Okay.